Okay, here we go. Number 1. Explain the difference between the coefficient of a power function and its degree. So in a power function, the coefficient is a real number which multiplies the variable, which itself is raised to a power. The variable is raised to a power. The coefficient is the real number in front of the variable, usually written that way, in front of the variable, which multiplies that variable raised to a power. So the degree is the highest power to which the variable is raised. Okay, and you can have even degree or odd degree. An even degree would be like raised to a power 2, 4, 6, 8, 10, so forth. Odd degree would be 3, 6, 9, 12, power 1 as well. That could be odd degree. All right. So one thing to remember when you raise a variable to an even degree, if you plug in a negative number into that variable, it will become positive. So for example, if you have, I don't know, 3x squared, if you have x equal to negative 2, that negative 2 is going to be squared, that becomes 4, and 3 times 4 is 12. So the negative will no longer be there, it's gone, right? It becomes positive. That even power will get rid of that negative sign for you, right? How convenient. Number 3, in general, explain the end behavior of a power function with odd degree if the leading coefficient is positive. So the coefficient in front is positive, and it has odd degree, like 1, 3, 5, 7, 9, and so forth. Now the thing about that is, if you plug in a negative number into that variable and it has an odd degree, it will still be negative after you raise it to whatever power it is. So for example, if x equals negative 2 and it's x cubed, right, you would have negative 2 cubed, which is negative 8. It would still be negative. So that's kind of the key to interpreting this problem. So you can think about it as x goes to infinity with this problem. That's positive infinity. F of x will go to positive infinity. Okay. So all the x's that are being plugged into the variable are positive, and they're getting bigger and bigger. That's what that means. And so the function itself will also become bigger and bigger and positive as well. All right. That's the leading coefficient is positive. Okay. So, for example, if you have, and it's an odd degree, so if you have 3x cubed, right? That's your function, f of x. X here is positive, and it's getting bigger and bigger. And x cubed is going to be positive as well, and that is positive. If that were negative, you would have negative times positive is negative. All right, but that's not the case here. So as x gets bigger and bigger, positive, this whole function gets bigger and bigger, positive, goes to positive infinity. Also, as x goes to negative infinity, what do you think? F of x will also go to negative infinity. This means that x goes to the left on the number line, right? Here's your number line. Here's x equals 0. And you have negative numbers going to the left, positive to the right. So as x goes this way, to the left, negative, negative cubed is still negative. Negative times positive is still negative, so that means f of x will go to negative infinity, all right, as x goes to negative infinity. All right, that's how that works. Number 5. What can we conclude if, in general, the graph of a polynomial function exhibits the following end behavior? Let me write this down, as x goes to negative infinity, x goes to negative infinity, f of x goes to negative infinity. And as x goes to infinity, positive infinity, f of x also, well, f of x goes to negative infinity. Uh-oh. So what can we conclude from that? Well, the polynomial function must be of even degree, and the leading coefficient must be negative. All right. So it's of even degree, and the leading coefficient must be negative. So, for example, it could be 3x squared. All right. So the x squared will make that positive, the x. Even though it's negative, you plug it in, it's going to become positive when you square it. All right, but it's still going to negative infinity, the function. So that means the leading coefficient is negative. Negative times positive is negative, right? So and the same thing applies here. X is positive, getting bigger and bigger. F of x is becoming more negative, going to the other direction, negative. And so you've got a negative leading coefficient. Okay, so let me write this out. So let's say f of x is, just for an example, a quadratic function, ax squared plus bx plus c. And here a is less than 0, where a is less than 0. In other words, a is negative. All right? A is the leading coefficient right there. Okay? So as x goes to negative infinity, all right, we have ax squared and then plus bx plus c. This a is always negative. All right, because we already specified that. That's a negative. All right. X squared, no matter what x is, x could be, well, x could be positive or negative. All right, but when you square it, it's going to always be positive. And it's going to get bigger and bigger as x gets bigger and bigger, or as x gets further and further to the left on the number line. All right, going to negative infinity, for example. So it's going to positive infinity. So negative times positive is negative, and this leading term here, you can call this the leading term ax squared, will overwhelm these two terms. All right, this c is just a constant. It always stays the same. It's not going to change. It's some real number. All right, so that doesn't really contribute too much in the long run, so to speak. This is a b times x, x to the 1 power. All right, compared to this does not get very big in absolute value. All right, so this is really overwhelming these two terms. This is the term you look out for when you look at end behavior. All right, the leading term, the one with the highest power in it. Okay, so it overwhelms the other two terms for a large absolute value of x, putting it in a more mathematical way of speaking. All right. Okay, number 7. I think we're supposed to identify these functions as to whether or not they're power functions. Okay, so we have f of x equals, and then it's x squared in parentheses, and that's raised to the 3rd power. Okay, so you're raising a power to a power, so you can simplify this by writing x to the 2 times 3, which is x to the 6. Raising a power to the power, you multiply the exponents. All right. Now notice that's not the same as x squared times x cubed, which is x to the 2 plus 3, or x to the 5. All right. So these are two different things. All right. This is x squared times x squared times x squared, x squared times x squared times x squared. That's x squared cubed. And now you can add the exponents just like you do here. That's 2 plus 2 is 4 plus 2 is 6. Okay, so that's a basic rule from Algebra 2, but it always bears repeating. Okay. Well, this is you can write a coefficient, just call that a 1. You can always do that. So it's a power function. All right, that is a power function. Number 9. We have f of x equals x squared all over x squared minus 1. Okay, this is not a power function, all right? This is what's known as a rational function, all right? Think of a rational number. It's a fraction, basically, all right? This is a function in fractional form, if you want to call it that. So it's a fractional or a function that's written as a fraction, all right, or a rational function. Okay, number 11. We have f of x equals 3 to the x plus 1. Is this a power function? No, because in order for it to be a power function, the variable has to be down here in the base, all right? And it cannot be in the exponent. There's the exponent, the variable's in the exponent, but it's not there, all right? What we have is a real number raised to this power, okay? But in a power function, the x should be down here in the base, not in the exponent. All right, so that's not a power function. Now here's something that has nothing to do with the problem, but I just thought I'd point it out. This is also equal to 3 to the x times 3 to the 1 power, or just 3. Or you could write that as 3 times 3 to the x. So you have the same base 3, you add the exponents, you get 3 to the x plus 1. All right, so that might help you when we get, especially into logarithmic and exponential functions. It'll help you to simplify some functions. And that's coming up soon. Okay, number 13. For the following exercises, find the degree and leading coefficient for the given polynomial. So we've got 7 minus 2x squared. Now if you prefer, you can write it like this: negative 2x squared plus 7, using commutative property of addition. All right, so that might make it more clear as to what you need to do. So the degree is 2. That's the highest power there. That's 2. And the leading coefficient, I'll call it LC, L dot C dot, equals negative 2. So there you go. Number 15, we have x times the quantity 4 minus x squared times the quantity 2x plus 1. Okay, so I can already tell what the degree is going to be, right? You have x to the 1 time, and you're going to have times x squared, that's x cubed, times x, that's going to be x to the 4th, all right? I don't know what the leading coefficient is just yet, so let's find out. We'll have to multiply this out. All right, so what I'm going to do is multiply these two binomials, all right? So this is 4 times 2x is 8x, and then 4 times 1 is 4. And then negative x squared times 2x is negative 2x cubed. And then negative x squared times 1 is negative x squared, like that. Alright, so multiply everything out. You've got x times 8x is 8x squared. X times 4 is 4x. X times negative 2x cubed is negative 2x to the fourth. And x times negative x squared is negative x cubed. And let's write this in descending order of powers, alright? So you start with the highest power and go down, descending order. So that's negative 2x to the fourth minus x cubed plus 8x squared plus 4x. Alright. So what's the degree? The degree is 4. And the leading coefficient is negative 2. Number 17, for the following exercises, determine the end behavior of the function. So we've got f of x equals x to the fourth power. Alright, so as x goes to negative infinity, what happens to f of x? Plug in negative numbers here and keep going to the left on the x-axis or in the number line. Alright, the even power will always make that a positive result. Alright, after you raise a negative number to an even power, you're always going to get something positive. So f of x will go to positive infinity. Alright, and if you go the other way on the number line toward positive infinity, so as x goes to positive infinity, what happens? Well, these are, put positive numbers in here. When you raise them to the fourth power, they're going to get stay positive. All right, so f of x will also go to, again, positive infinity. All right. Number 19. So f of x is almost like the last one, but it's a negative in front. So you can think of the leading coefficient as negative 1, negative 1x to the fourth if you want. Okay, so as x goes to negative infinity, what happens to this function? So think of x going on the number line to the left, and you're putting in negative numbers in here. You, according to order of operations, you use the power, you raise it to the power first, and then you multiply by the negative 1. All right, so you, when you raise that to an even power, that negative number becomes positive. Okay. However, then you're going to have negative 1 times that positive number, which means it's going to be negative. So that means f of x, the end result, of course, is negative. So f of x is going to negative infinity. And as x goes to positive infinity, what happens? You got positive numbers in here, raise them to the fourth power, they're still positive, but that negative in front is going to make the result, the end result, negative. So again, f of x will go to negative infinity. Number 21, we have f of x equals negative 2x to the fourth minus 3x squared plus x minus 1. Alright, so as x goes to negative infinity, what's going on with f of x? Well, the key is to look at the leading term, the term with the highest power, alright? Because it will dominate the other terms, because they are of lower powers, alright? And this negative 1 doesn't contribute much at all, okay? So whatever number you put in for x, when you raise it to the fourth power, it's going to be bigger, especially as x gets bigger in absolute value than these other two terms here. All right, and that's going to always stay at negative 1. So you look at the leading term to discover the end behavior. Okay, so as x goes to the left on the number line, all right, this is a negative number. Raise it to the fourth power, it becomes positive, but that negative 2 will make it negative, all right? So f of x goes to negative infinity. And as x goes to positive infinity, what happens? You could probably guess by now, or deduce it. All right, this is a positive number. Raise it to the fourth power, still positive. Multiply it by negative 2, it's going to be negative. So f of x will go to negative infinity. Number 23, we have f of x equal to x squared times the quantity 2x cubed minus x plus 1. Let's distribute that x squared through. Make it a little easier to work with. You're going to have 2x, when you multiply this times this, you're going to get 2x to the fifth. Add the exponents, 2x to the fifth, minus x to the 1 times x squared, that's minus x cubed. And then 1 times x squared, so that's plus x squared. So as x goes to negative infinity, f of x, well, this is an odd power, so whenever you plug in a negative number for x, it's still going to be negative when you raise it to the fifth power, an odd power. All right, so that's going to be a negative times positive 2 will still be negative. So f of x goes to negative infinity. And as x goes to positive infinity, that's positive. Raise it to fifth power, it's still positive, and multiply it by positive 2, it's still positive. So f of x goes to positive infinity. Again, you look at the leading term to determine the end behavior, all right, because it will dominate the others of lesser degree, all right, lesser exponents. Okay, so it will dominate, and it really determines the end behavior. Okay. Okay, number 25. For the following exercises, find the intercepts of the function. So intercepts, they're not being specific, so they must mean the x and the y. Or in this 25, we have t's, all right? So the t-axis would be the horizontal axis in this one. But we'll just call it x-intercept, all right? We'll be a little bit sloppy here, I guess, as long as we understand what we're talking about. T minus 1, t plus 2, and t minus 3. Okay, so let's look at the x-intercepts, or the t-intercepts if you want to be mathematically correct. Alright, the t-axis would be the horizontal axis. Where does this function meet or touch the horizontal axis? That's where f of t would equal 0. Alright, in other words, y, if you call y equal to f of t, y equals 0 when it touches the t-axis. Alright, So you set 2 times a quantity t minus 1, quantity t plus 2 times quantity t minus 3 equal to 0. Solve for t. Alright, well, this doesn't really factor in. You could divide both sides by 2 if you wish and simplify it. 0 divided by 2 is still 0, so you just end up with these three factors. Alright, the 2 will be gone, so you can kind of disregard the 2. Alright, so according to what I was taught, the principle of zero products, if you had 3 quantities being multiplied and they equal 0, then this equals 0, or this equals 0, or that equals 0. Alright, so that's how you solve these. T minus 1 equals 0, or t plus 2 equals 0, or t minus 3 equals 0. Alright, solve each one of those separately. This is very easy. T for this one, t equals 1, t equals negative 2, or t equals 3. Alright, so we have 3 t-intercepts, or x-intercepts, whatever you wish. We have 1, 0. In other words, t equals 1 and y equals 0. And we have negative 2, 0. And we have 3, 0. Alright, well, now let's find the y-intercept, which is very easy, usually. So we want to do the hard stuff first, you know, while we have energy, and then when we're all tired and bedraggled, we can do the easy stuff. Alright, so y-intercept is when x, or t in this case, when t equals 0. What's y? Alright, that's where the function meets the y-axis, when t or x equals 0. Alright, so all you have to do is do f of 0, and that's usually pretty easy. So you got 2 times 0 minus 1, and then 0 plus 2, and then 0 minus 3. So that's 2 times negative 1 times 2 times negative 3, and that equals 12. So we have the point 0, 12 as the y-intercept.